Welcome to the next lecture of ES300. Today is our last one where we're going inside an electric utility, and today we're going to talk about retail electricity rate setting. So we spent the last two classes talking about long-term system planning and short-term operations. Last time we talked about the different economic and engineering characteristics of different generators. We talked about the objective, the main objective, and constraints on power plant scheduling. And then we also talked about the different categories of power plants and how they're used within a portfolio of different power plants to meet fluctuating electricity demand. And we talked about baseload power plants, which would be nuclear and some coal plants, peaking power plants, which would be natural gas and hydropower, and then also the role of variable renewable energy. And so the upshot here was we wanted to figure out how system operators, whether that would be an independent system operator in charge of a deregulated wholesale electricity market or a monopoly utility, would use a portfolio of existing power plants to meet fluctuating electricity demand. So here are the quasi-final exam questions for today. There are three. The first one is, how are electricity prices for retail consumers determined? What causes these prices to go up or down? And then what are the different parts of an electricity bill? And how do they cover utilities' different costs? So the context for today is that we are a retail distribution company, and that could mean a utility operating in a deregulated state. So this would be a company that's buying electricity from a wholesale electricity market. An example would be PJM Interconnection. This is the system that stretches from the border of North Carolina and Virginia all the way up to New York, does not include New York, and then stretches over to Chicago. So each one of these colors on the map represents a different utilities footprint, and a distribution company that's associated with all of these different utilities would be buying electricity from the wholesale market. So to give you sort of a visualization of what that might look like here, we have in the top bubble here the wholesale electricity market, which is made up of the system suppliers. So that could be generation companies that are owned by utilities as well as independent power producers. Collectively, they all make up the system supply curve. That's who's producing the electricity in the wholesale market and who's buying the electricity from the wholesale market. The source of that perfectly inelastic vertical demand curve are the retail distribution companies. So those might be the distribution companies that are attached to the same utility that might own some generation that's producing in the wholesale market. And so the retail distribution companies are buying electricity from the wholesale market, and they are buying that electricity for the wholesale market price. So we also might be talking about a monopoly utility, and a monopoly utility in this case would be a company with exclusive control over a given geographical area. So a great example of a monopoly utilities is Duke Energy in North Carolina. And so what that would look like is a lot like what the world looked like before market deregulation all over the United States, where you have one monopoly utility who's vertically integrated, which means they own the generation, the transmission, and the distribution services. And they are selling direct electricity directly to retail customers from power plants that they own. Okay, so let's start with an easy question. What are retail electricity prices actually paying for? When we pay our electricity bill, where does that money go? What's the point? What costs that the utilities incur are we covering by paying for electricity? So the first one is infrastructure, right? We have to build all the stuff that we need to not only produce the electricity, but also transmit it over long distances. So high voltage transmission systems, substations that increase and decrease the voltage before and after the electricity is sent along high voltage transmission lines, as well as the retail distribution systems that are distributing electricity closer to the point of consumption at lower voltages. So the infrastructure that we're paying for represents a fixed cost for the utilities. Remember, utilities don't pay for infrastructure in cash. They borrow money to pay for that infrastructure. And the way it shows up on the utilities bills are as a constant fixed payment that they have to make, a mortgage payment, if you will, that they have to make to pay off the debt they acquire when they build all that infrastructure. And that debt is paid off over a long period of time. Other fixed costs that utilities might incur are fixed operations and maintenance costs. So these would be the costs of keeping the lights on in their facilities, paying people's salaries, etc. And just to review once more, how do utilities pay for infrastructure? Well, it's a combination of debt versus equity. We've talked about in the past how utilities traditionally have been more reliant on debt for a variety of reasons. It's a very capital intensive industry, so they really care at the interest rate at which they're financing this infrastructure. Debt is typically associated with a lower interest rate than equity. So most often, utilities are relying more on debt than equity. Now, the trade-off here is that debt has to be paid back, which is why it's a fixed cost. Paying off their mortgage is not an option. They have to do this legally. So every year, the utility would be responsible for making a mortgage payment on all its infrastructure that consists of two parts. The principal, so that's the actual money that they borrowed, the capital cost of the infrastructure, plus the interest that they have to pay off over a long period of time. And remember, we've seen this figure before. What this shows on the left y-axis is the annual payment that they're making. And so the orange line represents the total annual payment that a utility might make on a principal of $500 million over 25 years. So the annual payment they're making, which is principal plus interest, is on the order of $32, $33 million. And so they're making that every year for 25 years to pay off a $500 million debt. And you can see that the remaining debt, which is shown in green, gets paid off gradually, and the portion of their annual mortgage payment that is principal and interest changes over time. So it starts out mostly being interest, and then towards the end of the lifetime of the loan, that mortgage payment is mostly principal being paid off. So what's another cost that utilities have to pay for, other than the physical infrastructure itself? So the other is variable costs, and the main source of variable costs for utilities is actually the cost of fuel. It's a direct input-output relationship. The more electricity you want to produce, at least at thermal power plants, the more fuel you need. So what determines the variable fuel costs of meeting electricity demand? We talked about this last time. So the first one is demand itself. The higher demand is, the more electricity you have to produce. And then if you're using power plants that require fuel to produce that electricity, the more fuel you're going to need. And so electricity demand varies throughout the year. It's higher in the summer, at least in the Southeast, and it's higher in the winter in the Southeast and lower in the spring and fall. This figure actually shows an hourly electricity demand profile for PG&E, Pacific Gas and Electric in California, and they have very high electricity demand in the summer and pretty low demand during the rest of the year. So the variable costs associated with meeting that electricity demand also depend on what we're using, what types of generation we're going to use to meet that electricity demand. And remember, this mix of resources that gets used to meet electricity demand can vary from state to state. What this shows is the 2017 generation mix on average for the entire United States. So across the entire United States, on average, we're mostly using a combination of natural gas, coal, and nuclear, with a little bit of that coming from hydro, and then a growing share of that coming from variable renewable energy like wind and solar. But again, this mix varies tremendously on a state-to-state basis. So states that rely more on coal, their variable costs depend not only on electricity demand, but also on the price of coal. States that rely more on natural gas as a source of generation, their variable costs would increase with demand, but also increase with the price of natural gas. And that's sort of what this table shows. We have this different mix of different generation technologies, each of which is associated with a different variable cost, $1 per megawatt hour cost of producing electricity. And in several cases, at least for coal and natural gas, those costs are directly related to the price of fuel. And there's this range associated with natural gas here because traditionally the price of natural gas has been very low, but also very high at other times. And so also depending on the mix year, you could have increased fuel costs. For example, in a state with not much hydropower, not much wind and solar, where you're a lot more dependent on natural gas and coal, then increased demand is going to significantly increase fuel costs. But if you're in a state like Oregon or the state of Washington that has a lot of installed hydroelectric power, then maybe increasing electricity demand doesn't increase fuel costs that much because you're able to rely mostly on hydropower to meet that demand. And so the way we figure out what the variable costs associated with producing electricity is to optimize the use of these power plants in order to minimize the cost of meeting fluctuating electricity demand. So what we do is we find the least cost schedule of meeting electricity demand using all these different types of resources. And we talked about this last time. The typical way of doing this is to use nuclear because of its economies of scale and its low variable costs of producing electricity, but also because of its engineering constraints that limit its ability to ramp up and down production. Typically, those plants are used as baseload. Coal-fired power plants are a mixture of baseload and sort of shoulder demand, so they can increase or decrease output slightly, but not enough to be able to meet peak electricity demand. And then natural gas and hydroelectric dams are used as peaking resources, with wind and solar being used whenever the wind is blowing and whenever the sun is shining. So what would variable costs be for a retail distribution company who participates in a deregulated market? So remember, a retail distribution company in this case would be buying electricity from the wholesale market. So what we could do to estimate their fuel costs, essentially, or their variable costs, would be to add up the total wholesale electricity purchases that they make for the entire year. So every megawatt hour of electricity that they buy, and then we'd also need to know what price at which they're buying that. And again, in a competitive wholesale market for electricity, that price is going up and down all the time. And so that's what this shows. This is a figure again from that shows actual wholesale electricity prices in California from the summer of 2010. So as electricity demand is going up and down for this retail distribution company, it's likely that prices are also going up and down and up and down and up and down. And so by taking all of their demand for electricity and the prices at which they are paying for that electricity, we can get at their variable cost by multiplying their demand times their price, the price of electricity in every hour, and adding that up for the entire year. How about in a regulated market? So for a company like Duke Energy that's not buying electricity from a wholesale market, rather they're using power plants that they own, that they control to produce electricity, and then they're directly delivering that electricity to people in North Carolina. So what would Duke Energy's variable costs be? Well, it would just be the total variable cost of every single power plant that they use for the entire year. Instead of purchasing at a wholesale price of electricity, we would just say, what does it cost us to run all the nuclear power plants in the Duke Energy footprint, and all the coal plants, and all the natural gas plants, and all the hydro and wind and solar that Duke Energy uses to meet electricity demand. So that all the operational costs, not the cost of their mortgage, but the fuel costs associated with running these power plants, you add them up for the entire year, and that would be Duke Energy's variable cost. So the higher electricity demand is in a year, the more electricity the Duke would have to produce using coal plants or natural gas plants, and so their costs would go up. Likewise, if there was a mild summer and a mild winter, Duke Energy's electricity demand and Duke Energy's footprint was lower, they would be able to rely less on coal and natural gas to produce electricity, and their variable costs would go down. So we've got fixed costs, which are mostly the gradual payoff of the mortgage or debt on infrastructure, and then variable costs, which are mostly the cost of fuel that is necessary to produce electricity at some of these plants. So fixed costs plus variable costs, when we add them together, we refer to that as the operational costs. So this is the total cost of actually paying for the infrastructure and then using the infrastructure to produce electricity. Now, besides operational costs, what else are electricity prices supposed to cover? The answer is profits for shareholders. Remember, there's some investment that's made typically by shareholders in the actual infrastructure that we need to operate bulk electric power systems. So that could be, in the case of Duke Energy, power plants or transmission lines or distribution systems. And so some of that infrastructure is financed through equity. In other words, the utility is borrowing money from the shareholders, and the shareholders expect to make a profit on their investment. So let's take a look at the cost structure of a typical electric utility. So we have fixed costs, which are not dependent on how much generation is sold or electricity demand. And that's mostly debt repayment on infrastructure, as well as fixed operational costs like operations and maintenance and salaries, the costs of keeping the lights on. And then we have variable costs, which are directly proportional to electricity demand. And these would mostly be fuel costs. On top of that, we also have return on equity or profits for shareholders. So this triangle or this pyramid is supposed to represent the typical cost structure of an electric utility. And what you can see is that the biggest source of costs, of annual costs for an electric utility, are fixed, right? So that's the fixed operations and maintenance, but also a big chunk of that are the mortgage payments they have to pay on the debt they acquired to build all the infrastructure. And then there's a slice of it that's the variable costs. So the fuel that's needs to be purchased to produce the electricity at some of these power plants. And then on top of that, profits for shareholders. So this, in essence, is what retail electricity prices are supposed to cover. They are supposed to cover mostly fixed costs and then variable costs and then profits for shareholders.